So this is a presentation on our project CubePhysics by Boris Tsyganok and Zach Benusic. So what does CubePhysics do? CubePhysics intends to simulate the basic translational kinematic systems between two objects, ignoring the rotation or any further calculations involving inertia. It aims to immerse the viewer in the world of the objects by simulating a 3D view. So when we consider the rendering component, here's an illustration. We can think of it as a viewpoint, which is going to be the player's perspective. They'll be looking from right here. There's going to be a screen that will actually be what we see on our screen. That will be a projection of the objects with respect to the player's position, so we can draw lines going to a specific point and project where that would be on this screen, and that's what the player would actually see on their monitor. So we would have a screen, there'd be objects in the world, and these objects will have this polygon system. This would be what would get rendered. And all objects will be made out of those triangles, and comparing the distances, so this distance between an object and a player, and the screen and the player can be used to shrink or enlarge the object's position so that it appears you are close or far away from an object. So how can we use linear algebra to simplify this problem? First, we can translate all of the coordinates of the objects to consider the player's point from which they view everything as an origin. This will later allow us to rotate all objects such that the player's current view, will say in this diagram the player is viewing some amount of angle up, will be focused back to have the x-axis be the center of view, and so the polygon is stored as a triangle or a set of triangles, each with 3 points. Now we can take these 3 points and convey it as two vectors from some origin point, this line and this line. And we can actually take the cross product of those two lines to give us a perpendicular line from the plane of this triangle. And we can see if that line, if its x component is facing towards the view or away. Now, if it's facing away from the view, then we can say that it's not going to be a triangle you will see from your perspective. If it is facing towards you, then we actually will have to draw the triangle. From our prior rotations, the distance from the viewer can be simply said as the x value of our point, because the center of view is the x-axis. And we can use this simplification to project the dot positions of this triangle onto the screen simply by using the ratio of screen distance to the x position of a point, with screen distance being some variable we set that is fixed. So what did developing CubePhysics teach us? It taught us how to use class-based coding systems in MATLAB, where we used classes for polygon and for physics object. It taught us to take basic inputs, basic keyboard inputs passively from the keyboard without input prompts, so without having the console ask for the person to input anything. It taught us some practical applications of linear algebra and matrix-based operations, such as the rotation, the cross product, and all those other things, and how they can be applied for rendering methods. It taught us how to separate a large task, like handling the calculations on the back end and rendering the front end, into smaller, easier to manage subtasks and methods. As I mentioned, we can divide the work done at the back and at the front into separate classes that will handle it separately, which will lead to much smoother code, and how physical calculations can be used to simulate motion.